Today we'll solve the remaining numericals of AC circuits chapter. A capacitor of 100 microfarad, a coil of resistance of 50 ohms and an inductor of 0.5 Henry are connected in series with a 110 volt 50 Hz source. Calculate the RMS value of current in the circuit. So, solution, this is a LCR series circuit and we have been given the capacitance C equal to 100 microfarad, which can be written as 10 raised to minus 4 farad, and R equal to 50 ohms, and L is also given 0.5 Henry, and from here we can easily say that ERMS is equal to 110 volt and frequency is given to us as 50 Hertz, and we need to find out the IRMS value for the circuit. So IRMS is given as, for a series LCR circuit, ERMS upon Z. Now we can say that ERMS is 110 volt, but we need to calculate the value of Z, and for a series LCR we know Z is given to us as root under R square plus the reactance, that is XL minus XC square. So first of all, XL can be given as omega L, which is equal to 2 pi FL, which is equal to 2 into 3.14 into F, which is 50 into L, which is 0.5, and solving this we get XL equal to 157 ohms. Similarly, XC, which is equal to 1 upon omega C, can be written as 1 upon 2 pi FC, which is given as 1 divided by 2 into 3.14 into F, which is 50, and C, which is 10 raised to minus 4 farad. And solving this we get XC equal to 31.84 ohms. Now let's calculate the reactance of the circuit, which is given as XL minus XC, which can be written as 157 minus 31.84, which is equal to 125.16 ohms. So let's calculate the value of impedance, that is Z, which is equal to root under R square. So R square, which is 50 square, so 50 square plus 125.16 square, that is 125.16 square. Now taking the square of these both term and adding them, we get root under 18165.03, and calculating its root we can say that Z is equal to 134.7 ohms. So now let's find out the value of IRMS. So IRMS is equal to ERMS upon Z. So ERMS is 110 upon Z, we found out 134.7 ohms. So calculating this we get IRMS as 0.816 ampere. I hope you understood this sum. Let's look at the next sum. Find the capacity of the capacitor, which when put in a series with a 10 ohm resistors make the power factor equal to 0.5. Assume an 80 volt 100 hertz AC supply. So solution, this is an RC series circuit and we need to find out the capacitance of the capacitor, where the resistance is given to us as 10 ohms and the power factor, which is cos phi, equal to 0.5, and from here we can say that ERMS is equal to 80 volt and frequency is 100 hertz. So we know the expression for power factor, that is cos phi equal to R upon Z. For an RC series circuit, Z is equal to root under R square plus capacitive reactance square. Let's check out first this thing. Now we know cos phi is 0.5, so 0.5 equal to R is 10 and Z, so Z can be written as 10 divided by 0.5, which is equal to 20 ohms, and from here we can take calculate the value of XC, which implies XC equal to root under Z square minus R square, which is equal to Z square is 20 square and R square is 10 square, which is equal to 400 minus 100, which can be written as root under 300, and calculating the root of 300 we get X equal to 17.32 ohms. Now from here we can say that Xc is given by 1 upon omega c, which implies C is equal to 1 upon omega into xc. Omega is given as 2 pi f into xc. So putting all the value, we get C is equal to 2 into 3.14 into f is 100 into xc is 17.32 ohms, and calculating this we get the capacitance, which is equal to 9.2 microfarads. Micro means 10 raised to minus 6. I hope you understood this sum. Let's look at the next sum. Find the time required for a 50 Hz alternating current to change its value from 0 to the RMS value. Now we know that an AC current flows like this, and this is the I naught value, and this is the 0 value, and the RMS value is somewhere between here. Okay, so we need to find out that what is the time that is required for a current to go from 0 to RMS, that is for a current to go from here to here, how much time is required. So we have been given here frequency, which is equal to 50 Hertz. So let's write the expression for instantaneous value of current, that is I equal to I naught into sine omega t. So we need to find out the time at which the current value, that is I equal to its RMS value, which implies that writing this here we can say that I RMS is equal to I naught into sine omega t, and we need to find out this time. So we know that I RMS is equal to I naught upon root 2. So writing this here we can say that I naught upon root 2 is equal to I naught into sine omega t. So I naught gets cancelled, and we can say that 1 by root 2 is equal to sine omega t. Now taking the sine here, we can write it as sine inverse of 1 by root 2 equal to omega t. We can say that sine 45 is 1 by root 2. So sine inverse of sine 45 degree is equal to omega t. Sine and sine inverse get cancelled, so this is 45 degree equal to omega t. Now we know that omega is given in radian per second, so we need to convert this degree into radian. So 45 into pi by 180 is equal to omega, which can be written as 2 pi f into t. Now this implies that t is equal to 45 pi by 180 into 2 pi f. So pi gets cancelled, and 45 ones are 45 fours are, and 4 twos are 8. So t can be written as 1 by 8 into frequency, which is equal to 50 Hertz, and 8 into 50 is 1 by 400. T is, solving this we get t equal to 2.5 into 10 raised to minus 3 seconds. I hope you understood this sum. Let's look at the next sum. Calculate the value of capacity in picofarads, which will make 101.4 microhenry inductance to oscillate with frequency of 1 megahertz. So solution, this is a sum of LC oscillation. So we have been given a frequency which is equal to 1 megahertz, which can be written as 10 raised to 6 hertz, and we need to calculate the capacity in picofarad for a inductor which has a value of 101.4 microhenry, that is L equal to 101.4 microhenry, which is 101.4 into 10 raised to minus 6 Henry. So we know that for an LC oscillation, F is equal to 1 upon 2 pi root under LC, which implies in order to calculate the capacitance, we can say that squaring on both the side, which will give us 4 pi square F square equal to 1 upon LC, which implies C is equal to 1 upon 4 pi square F square L, which is equal to, now putting all the values, 4 into pi square, that is 3.14 square into f square, that is 10 raised to 6 square, which will be 10 raised to 12 into L. L is 101.4 into 10 raised to minus 6. Now 10 raised to 12 into 10 raised to minus 6 will give you 10 raised to 6, and when this 10 raised to 6 goes up, it will be 10 raised to minus 6. So we can say that C is equal to 1 upon 4 into 3.14 square into 101.4 into 10 raised to minus 6. Now calculating this, we get 1 divided by 3999.05 into 10 raised to minus 6, which will be equal to 2.5 into 10 raised to minus 4 into 10 raised to minus 6. Now 10 raised to minus 4 and 10 raised to minus 6 is 10 raised to minus 10. But we need to find out the capacity in picofarads. Now picofarad is 10 raised to minus 12. So taking this point 2 decimal forward, we can write C is equal to 250 into 10 raised to minus 12 farad, which can be written as 250 picofarad. So this is the value of the capacitance in the LC oscillation. Let's look at the next sum. A 10 microfarad capacitor is charged to a 25 volt of potential. The battery is disconnected and a pure 100 millihenry coil is connected across the capacitor so that LC oscillations are set up. Calculate the maximum current in the coil. So we have been given a capacitance value C equal to 10 microfarad, which can be written as 10 raised to minus 5 farad to a 25 volt of potential, that is ERMS is equal to 25 volt. Now the battery is disconnected and a pure 100 millihenry coil is connected across the capacitor so that LC oscillation are set up. So the inductance is given to us as 100 millihenry, which can be written as 100 into 10 raised to minus 3 henry, which is equal to 0.1 henry. Now when the battery is disconnected and the inductor is applied at that place so that LC oscillations can happen, we can say that the energy stored in the capacitor will be equal to energy stored in the inductor, that is EC will be equal to EL from the conservation of energy perspective. So we know that energy stored in capacitor is given as half CV square, which is equal to energy stored in inductor, which can be given as half Li square. So half gets cancelled, and from here we can calculate the value of current, that is I square can be written as CV square by L. So we know C is given as 10 raised to minus 5. V square is nothing but the value of the battery, that is 25 volt. So 25 square is 625 divided by L. Now we know L is 0.1. So from here we can say that this 0.1 is 10 raised to minus 1, and when this goes up this will become 10 raised to 1. So this will be 10 raised to minus 4. So I square is equal to 10 raised to minus 4 into 625. Now taking square root on both the side, I can be written as 10 raised to minus 4 into 625. So when this 625 comes out, this will be 25, and 10 raised to minus 4 comes out, this will be 10 raised to minus 2. I will be equal to 0.25 ampere. So the current in this LC oscillation is 0.25 ampere. So let's look at the last sum of this chapter. A 100 microfarad capacitor is charged with a 50 volt source supply. Then source supply is removed and the capacitor is connected across the inductor, as a result of which 5 ampere current flows through the inductance. Calculate the value of inductor. This is also a sum of LC oscillation where a capacitor is charged by using a 50 volt source, and the source is removed and a inductor is connected so that LC oscillation should happen, and we need to calculate the value of the inductance for which the current is 5 ampere flowing in the circuit. So again we know that energy stored in capacitor is equal to energy stored in inductor from the conservation of energy perspective. So half CV will be equal to half Li square. So from here we need to calculate L. So we can say that half of gets cancelled and L is equal to CV square by I square. Now C is given to us as 100 microfarad, which can be written as 10 raised to minus 4 farad into V square, that is 50 volt. So 50 square is 2500 divided by I square. I square is I is 5 ampere, so I square will be 25. So this will become 100, and 10 raised to minus 4 into 10 raised to 2 will be 10 raised to minus 2. So L will be 10 raised to minus 2 Henry, which can be written as 0.01 Henry. So this was the last sum of this chapter. Thank you for watching.